Is that a duck? Is it a flag? Who knows? All right, hopefully you paused the video earlier. If you didn't pause it, here I am. Rock me like a hurricane. Just watch Trolls World Tour. Don't do that. And 6 minus 3 is positive 3. Why am I staring at the microphone? You're right there. All right, I want to jump in to lesson 10-5. Wait, greetings. Okay, we're just going to try and knock through several of the examples in lesson 10-5. We're looking at the distance formula today. Distance formula is a way to describe distance, specifically distance in the coordinate plane. Unsurprisingly, based on our last lesson, it is connected to Pythagorean theorem. So let's jump right in. I'm not going to go with the formula at first. I just want to see this example. Example 1, find the distance between the point. Oh, let's write down example 1. Find the distance between the points 2, 3 and -4, 6. So first of all, let's get those points down. 2, 3 and -4, 6. Okay, so we're looking at these 2 points and we have a choice right now. Behind door number 1 is a formula. You can memorize the formula. Presuming you can plug numbers correctly into the formula will return the distance between these 2 points. But behind door number 2 is true understanding. We can actually understand how to find the distance between these 2 points and why the distance is what it is based on something we already know. Unsurprisingly, I want to look behind door number 2. So let's think about what's going on here. Now, distance is not difficult to count if we're simply counting up and down or left and right. So here's what I mean by that. We have these 2 points, and there's no question what their vertical distance is. We can very clearly see that they're 3 units apart, counting up and down. And similarly, there is no question what their horizontal distance is. We can again very clearly see that they're 6 units apart, left to right. Lo and behold, once we've drawn this, we can see a right triangle. And we can find the hypotenuse of that right triangle, which happens to match the distance we're interested in, by using the Pythagorean theorem that we saw in the last lesson. So if we call this distance d, we can say right now that 3 squared plus 6 squared equals d squared. We can then go ahead and compute this. 3 squared, of course, is 9. 6 squared, 36, equals d squared. 45 equals d squared. We can take our square root on both sides, and we can get that the square root of 45, whatever that is equal to d. We could go to the calculator if need be, and we could say, oh, that's pretty close to 6.7-ish, I bet. Should we find out? Square root 45. Oh my gosh, 6.708. So we could say, well, that's about 6.708. Or even better, based on the work that we've done in this chapter, we could take a look at 45 and say, well, wait a second, that's the same thing as 9 times 5. We can take the square root of 9, so we can say d equals 3 root 5. So this distance d here is equal to the square root of 45, or 3 root 5, or approximately 6.7. Any of those answers are permissible depending on the scenario. So that's door number 2, and that's my preference. Door number 1 looks more like this. We have this magic formula. From whence it comes we do not know. D equals big square root sign, big set of parentheses squared, big set of parentheses squared, a minus and a minus. And in these spaces go what we call x2. Oh my gosh, no. What we call x2, x1, y2, and y1. And you might wonder, well, what on earth are they talking about? If we go back to our picture from earlier, this point was 2, 3, this point over here, -4, 6. The x1s and the x2s, much like in our slope formula or our point slope formula for a line, are simply x coordinates. The order really doesn't matter. In fact, it really doesn't matter for a reason we'll get into later. And so I'm simply going to plug in -4 and 2 for those x coordinates. And then we go back up here and we want to pick out the y coordinates. In this case, 6 and 3. And we can go in here and we can plug in 6 and 3. -4 minus 2 is -6. And 6 minus 3 is +3. Now these numbers, first of all, you should be able to tell why the order doesn't matter. Whether we had gotten 6 or -6, either way when we square it, we get 36. Whether we had gotten 3 or -3, either way when we square it, we would get +9. So this is why we say the order doesn't matter for the x coordinates or the y coordinates. As long as you're subtracting x coordinates from x coordinates and y coordinates from y coordinates, you're set, you're good to go. But you might recognize, wait, these are the same numbers that we saw up in our Pythagorean theorem, right? 3 and 6. And again, when we square them, we're just going to get d equals the square root of 36 plus 9. D equals the square root of 45, right? And then we can do the same simplification we did earlier or the same approximation that we did earlier. But either way, it's the same answer. The numbers are even the same. The only difference is that when we're just using a right triangle in the coordinate plane, we can just keep using Pythagorean theorem. We don't have to memorize any special formula. If you want to memorize the special formula, great, it will definitely work. There's even an example later on in this lesson where it kind of comes in extra handy, although even in that case I'll show you there is, I think, a better way to approach the question. But that's all we're doing here. I don't care which method you use. You want to use the formula, use the formula. You just want to draw right triangles in the coordinate plane, draw right triangles to your heart's content. Take a moment and work out check your progress number 1 from the bottom of page 547 while I do the same. So I went ahead with door number 2 once again. We've got these 2 points, 4, -1, that's right here, and then -2, -5, that's right there. We can count vertically, they are 4 units apart, that's the 4. Left to right horizontally, they are 6 units apart, that's the 6. 4 squared plus 6 squared equals d squared, and then we can eventually find that d should be the square root of 52. We can approximate that. Let's see how close I got. Square root of 52. 7.21, pretty good. So 7.2 is approximately that distance, and that's exactly the same thing as 2 root 13, because we can simplify that root 52. We can simplify the radical. Example 2, Tracy's golf ball is 20 feet short and 8 feet to the right of the cup. On her first putt, the ball lands 2 feet to the left and 3 feet beyond the cup. If the ball went in a straight line, how far did it go? Okay, so in this application, you can kind of get a sense of why the distance formula might make more sense in some cases. 20 is a big number. Let's say I don't want to draw a coordinate plane where I put 20 somewhere. This time I am simply going to plug into the formula something minus something squared plus something else minus something else squared. And the something else here are our x coordinates and our y coordinates. So our x coordinates, somewhere way over here, 8 comma negative 20. So that's an x and y coordinate pair. And then somewhere over here, negative 2 comma 3. Obviously my drawing is not to scale. This is the distance that we're interested in. Our x coordinates we can plug in negative 2 and 8. Our y coordinates we can plug in 3 and negative 20. Negative 2 minus 8 is negative 10. 3 minus negative 20 is 23. But again, order really doesn't matter because when we square these, whether they were positive or negative, they're going to become positive now. Negative 10 squared becomes positive 100. 23 squared becomes 529. We want to add these together and take the square root. So d ends up being the square root of 629, which is, let's change colors, just a little bit bigger than 25. I bet it's about 25.1. If we needed to say what it is exactly, it looks like maybe 3 goes into this, but it does not. It's not even, so 2 obviously doesn't work, 4, 5, 6, none of that works. 7, 56, no. 8, 9, 11, is 629 prime? 629 divided by 11, no. Divided by 13, no. Divided by 7, oh my gosh, it's 17 times 37. That's ridiculous. Well, 17 and 37 are both prime, and so this does not simplify any further. So there's our answer. The distance between where she hit the ball at first and where she is hitting the ball now is root 629, or about 25.1. Now I mentioned earlier that we didn't need to do it, or this was one of the places where we might actually want to use the distance formula, but even here you can still get a sense of why the right triangle method would be helpful. Again, if I'm looking at just my x coordinates, I can tell, oh, of course those are 10 units apart. So even if it's not to scale, I can still write down that they're 10 units apart. And then again, positive 3 all the way down to negative 20, I should be able to tell, oh, well, that's 23 units apart. And so there is our 10, 23, D right triangle. 10 squared plus 23 squared equals D squared. Same math, of course, 100 plus 629 equals D squared. I'm sorry, 529. 629 total equals D squared. D equals the square root of 629, which again is about 25.1. Take a moment and check your progress number 2 on your own. Okay, so here's my work for check your progress number 2. Part of the hard part here, I guess, is trying to figure out how to place the points. But again, presuming the cup itself is at the origin 0, 0, 12 feet past. So this direction I'm saying is past. This is in some sense beyond, using their language. So 12 feet past the hole, 3 feet to the left. Left and right here is pretty simple. Her first putt goes 2 feet beyond the cup and then 1 foot to the right. So that's going to be 1, -2. You can see that's the work with the distance formula that we get exactly 2 root 53 after we simplify, which is apparently approximately 14.5. So her putt from here to here, right past the cup, traveled about 14.5 feet. Again, if need be, you could do this with a right triangle. Let's do some highlighter. From here all the way down and here all the way over, you can see, that's where the 4 comes from. And this is where the 14 comes from. So we're looking at a right triangle 4 by 14. A squared plus b squared equals c squared. You're going to get exactly the same answer. Example 3, which is the last example in this lesson, is a little more interesting. So let's look at example 3. And again, there's a way to do this with the distance formula, very straightforward-ish. And if you want to do that, that's fine. But I'm going to start with the way the book does it, the formula way. So find the value of a if the distance between the points at 7, 5 and a, -3 is 10 units. So first of all, let's sketch out a picture of what's going on here, just so we have some understanding. 7, 5. Right up there, right? 7, 5. And a, something we don't know, -3. So -3, of course, a y-coordinate of -3 would be somewhere down here. But again, we don't know where. It's just a, -3. So something, -3. And so there is some distance, some direction. Obviously, if we went straight down, we would see a distance of 8. And so it must be that it's kind of tilted out. Maybe it's this way, maybe it's this way. We'll talk more about that in a second. But there's some distance that we're told is 10 units long. And again, I don't know what direction it is, one of these two directions. And this point where it meets, either here or here, is something, -3. But again, we don't know where the something is. So if this picture doesn't really make sense to you, that's fine. I'm going to come back to the picture. Let's ignore the picture. Let's just say distance equals square root something minus something squared plus something minus something squared. Our somethings, of course, are going to be the x-coordinate, which is a, and 7. And then the y-coordinates, which are -3 and 5. And a minus 7, of course, is just going to stay a minus 7. And of course, we want to square that. But actually, d we can replace because we know what the distance is. We were told in this case that the distance is 10. And then the -3 minus 5 is -8 squared. And we know that to be 64. Now at this point you might recognize, we have a radical equation. And so we're going to solve this radical equation by doing what we always do, squaring both sides to get rid of the radical. 10 squared, of course, is 100. And on this side, we just cancel the radical and the square. And so we get a minus 7 squared plus 64. And then from here, we could subtract 64, 36 equals a minus 7 squared. take a square root. Again, canceling the square and the square root. Square root of 36 is positive or negative 6. So this is a reason why we are going to end up with two answers in this case. Positive or negative 6 equals a minus 7. Finally, add 7, and we get that 7 plus or minus 6 is a. 7 plus 6, of course, is 13. So one possibility is that a is 13. 7 minus 6 is 1. And so another possibility is that a is 1. In other words, if we go back to this, and I swear I did not plan this, you can see I ended up almost on exactly those points. Apparently, this point over here would be at 1 comma negative 3. Now I know on my graph it looks like 2, but again, I was just sketching. That's pretty close. This point over here would be 13 comma negative 3. On my graph I put it at 12, but again, that's pretty good. That's pretty close. So the picture should clue you in onto why we end up with two answers here. Again, this vertical distance right here is definitely 8. We can count that because I'm looking at a y-coordinate of 5 and a y-coordinate of negative 3, and that has to be 8. So there's no doubt about that vertical distance. The horizontal distance we don't know, but we know that the slanted distance has to end up being 10. That's where this 10 came from. But you can see it could go in either one of the two directions, right? There's nothing special about doing it on the right versus the left. In fact, another way to think about what's going on in this question is that when we say we start at a certain point, and then we definitely want a distance in any direction, any particular direction, but we definitely want that distance to be 10, well, what kind of object is the same distance from a given central point? The answer is a circle, right? And so basically, everywhere that this circle intersects that y-coordinate line that we were interested in is a possible solution to this kind of problem. In this particular case, you can see it intersected twice. And again, the algebra with the distance formula shows us that happens at 1 and it happens at 13. Whether you do the algebra or whether you do the geometry in the coordinate plane is up to you, but either one of them will actually work. Go ahead and take a moment and work out Check Your Progress number 3. I'm actually going to talk through this one because I imagine this problem was a little bit weird. Find the value of a if the distance between the points 3, comma a. So this time they start us off with the unknown, 3, comma a, and negative 4, comma 5. Well, negative 4, comma 5, we know where that is. So let's start with the one that we know, negative 4, comma 5, somewhere over there. I'll even write it down, negative 4, comma 5. And again, 3, comma a, we know that it has to be somewhere over here because that's where the x-coordinates of 3 all are. And we know that the distance is root 58. Well, let's think about distances. This distance here is obviously 7, right? So I'm going to write that down. And then root 58 is actually just a little bit bigger than 7. I guess it's a little closer to 8, but it's like 7.6. So the distance is not far. I want to go, not very different from 7, I should say. I want to go like maybe like that. So that's 7.6-ish, or again, maybe down here, right? But one of these 2 points is going to be what we're interested in. Let's not say approximately 7.6, because we don't know what that is, but let's say exactly root 58. You can tell in this case we could actually do this question with our Pythagorean theorem and a right triangle. Let's say we call this, let's not call it a because that might get confusing. Let's just go ahead and call it x, a classic. 7 squared plus x squared equals root 58 squared. 49 plus x squared equals 58. The square root of 58 squared obviously is 58. So x squared on its own, if we subtract our 49, must be 9. X equals 3. But again, when we take the square root here, it's positive or negative 3. Either we're going to go up 3 from here, or we're going to go down 3. If we go up 3 from a y-coordinate of 5, we end up at 8. So a could be 8. And again, that comes from 5 plus 3. If we go down 3 from a y-coordinate of 5, could be at 2. So a is 8 or a is 2. If you don't like the geometry, that's no problem. Let's just do the algebra. Square root of something minus something squared plus something minus something squared. Plugging in our points, -4 and what was the other x-coordinate? 3. And our y-coordinates, 5 and a. And again, the order makes no difference, so let's just put the variable first. That's generally easier. -4 minus 3 is -7. A minus 5 just stays a minus 5. Everything else stays in red. Squared, squared, square root. D equals the square root of 49. Wait, not D. We know what the distance is. Oh, I didn't mean to do that. Root 58, because that's what we're told the distance, equals the square root of 49 plus a minus 5 squared. And now it should be pretty obvious that when we square both sides, both these radicals and squares cancel. We end up with 58 equals 49 plus a minus 5 squared. And again, this should start to look very familiar compared to the work we were doing with the triangle, the right triangle in the coordinate plane. Subtract the 49, subtract the 49, 9 equals a minus 5 squared. Take the square root, take the square root. Positive or negative 3 equals a minus 5. Add the 5 over, add the 5 over. A equals 5 plus or minus 3. 5 plus 3 is 8. 5 minus 3 is 2. Same exact answer either way we do it, right? So there we go. That is lesson 10-5. Distance formula is simply Pythagorean theorem in the coordinate plane, written in kind of a funky way. You want to memorize the formula, memorize the formula. You want to draw right triangles in the coordinate plane, like moi, draw right triangles in the coordinate plane, whichever way you're more comfortable with. You want to draw circles in the coordinate plane, draw circles in the coordinate plane. All this stuff will work, presuming you understand it. Oh yeah, comment down below with your questions and comments. Is that what people say on the YouTube? I don't know.